From the iconic B-1 Lancer to the revolutionary B-52 and the silent might of drones, discover how air power is rapidly transforming. While not as immediately recognizable as bombers such as the B-2 Spirit or the B-52 Stratofortress, the Rockwell B-1 Lancer has, for nearly 5 decades, become one of the United States military's most crucial assets. Introduced in 1974, the B-1 is a supersonic, variable-sweep wing strategic bomber developed by Rockwell International, which later merged into Boeing. Similar to the F-14 introduced around the same period, the Lancer can adjust its wing configuration from a standard spread to a swept-back arrangement depending on mission requirements. Despite measuring 44.5 meters in length with a wingspan of 41.75 meters, the B-1 can achieve speeds exceeding 1,287 kilometers per hour and travel over 11,112 kilometers. Over the years, it has been deployed in conflicts ranging from Yugoslavia and Afghanistan to Iraq. To maintain relevance amid rapid technological advancement, the B-1 has undergone multiple block upgrades and system improvements. Many of these enhancements focused on expanding its payload capacity or integrating new types of ordnance. In 2012, the United States Air Force launched the Integrated Battle Station (IBS) upgrade program. This initiative consolidated 3 separate upgrades, including the Fully Integrated Data Link (FDL), Vertical Situational Display Unit (VSSDU), and Central Integrated Test System (CITS). The FDL enabled electronic data sharing between aircraft and command networks, while the VSSDU replaced traditional flight instruments with multifunction color displays, including a screen dedicated to threat avoidance and targeting. The CITS serves as a comprehensive diagnostic tool, allowing the crew to monitor more than 9,000 parameters and proactively prevent system failures. The B-1 can carry up to 22,680 kilograms of ordnance across its 3 bomb bays. In addition, it has 6 external hardpoints, designed to deploy a diverse array of bombs simultaneously. The B-1 has multiple pre-configured weapons loads defined by the U.S. military. Among its less commonly used armaments is the MK62 Quick Strike Mine, essentially a modified Mark 82 unguided bomb. These mines are typically assembled shortly before loading onto the aircraft, giving ground crews familiarity with the weapons before they are carefully stowed in the bomb bays. Loading ordnance onto a bomber is an intricate and labor-intensive task. Multiple bombs can weigh several hundred or even several thousand kilograms each. As a result, specialized equipment is required to transport them across the tarmac and raise them into the bomb bay. The bombs must then be arranged carefully ahead of the upcoming mission because not all bombs are appropriate for every planned kind of attack. Although classified as a heavy bomber, the B-1 presents a silhouette reminiscent of a larger fighter aircraft. It combines speed and maneuverability with the ability to carry anti-ship and anti-aircraft missiles for self-defense in hostile airspace. Its 4-person crew, consisting of an aircraft commander, pilot, and both offensive and defensive systems officers, wear standard flight gear on most missions. Crew members access the 10.36-meter high fuselage via a hatch located beneath the cockpit. Inside, they have access to a fully modernized aerial battle station, allowing for advanced mission management. The B-52 Stratofortress may ultimately become the first military aircraft to serve for a century. First entering service in 1955, this long-range subsonic strategic bomber has remained a cornerstone of the U.S. fleet ever since. Like the B-1, the B-52 has undergone numerous upgrades over the decades. The latest variant, the B-52J, will incorporate new Rolls-Royce F-130 engines and a fully modernized radar suite. This upgrade will also modernize the cockpit, largely unchanged since the 1950s, providing enhanced digital systems and improved integration for faster pilot response times. The redesigned interior will streamline controls and improve situational awareness. Despite these advancements, operating a B-52 remains largely consistent with practices developed over the past 7 decades. Originally designed for nuclear deterrence, the Stratofortress has also been widely employed in conventional bombing campaigns. Its substantial payload capacity allows deployment of guided and unguided bombs, cruise missiles, and air-launched ballistic missiles. Mission-specific roles vary, but the aircraft is primarily tasked with strategic deterrence, close air support, and precision strike operations. At over 45 meters in length, the B-52 can carry up to 31,750 kilograms of ordnance in its 2 internal bomb bays, providing immense strike capability against a variety of targets. Since the 1950s and 1960s, the aircraft has been modified to carry both conventional and precision-guided munitions, including bunker busters and specialized bombs. Additionally, it can launch long-range cruise missiles, significantly extending its reach to targets that would otherwise be inaccessible. The B-52's adaptability has proven unmatched, and experts estimate that it will remain operational for another 30 years following the completion of current upgrades. One of the earliest military drones was the MQ-9 Reaper, a remotely piloted aircraft introduced in 2007. Since its debut, the MQ-9 has flown thousands of missions worldwide, demonstrating the effectiveness of unmanned aerial platforms. The benefits of autonomous and remotely piloted aircraft extend beyond eliminating onboard crew risk. Systems such as the MQ-9, MQ-20, and MQ-1 typically require less maintenance than manned combat jets. Nevertheless, these platforms demand regular human inspection to ensure operational reliability and prevent in-flight failures. Before every mission, drones undergo comprehensive pre-flight inspections, covering the airframe, control surfaces, payload modules, sensors, and communication links. The MQ-9 Reaper also follows a manufacturer-specified maintenance schedule, including periodic inspections, component replacements, and system verifications, with some elements requiring routine checks or replacement. Ground control stations, GCS, for the MQ-9 Reaper, feature an array of monitors and control interfaces. When operating manually, the drone requires two trained personnel, a pilot and a sensor operator. The sensor operator manages cameras, executes checklists, and supports both the pilot and external teams, while the pilot focuses on flight direction, altitude, and positioning. Each GCS console provides joysticks, keyboards, and switches to manage flight control, sensor operation, and payload functions, enabling operators to control takeoffs, landings, navigation, and mission execution while interfacing with onboard systems. Situational awareness is a primary challenge for UAV operators, necessitating extensive simulator training to prepare them for varied scenarios without physically being on board the aircraft. Across the globe, drones are increasingly deployed for tasks that might otherwise be difficult, costly, or time-intensive. Their relatively low cost compared with manned aircraft allows even smaller militaries to enhance surveillance and defensive capabilities. Modern air power is no longer defined by a single aircraft type or mission profile. From the speed and payload of the B-1 Lancer to the enduring adaptability of the B-52 and the growing prominence of unmanned platforms, aviation now functions as a layered, interconnected system. Manned bombers, remotely piloted aircraft, and next-generation drones operate collaboratively, with each complementing the others. This integration of legacy aircraft and advanced technology illustrates a future where precision, persistence, and flexibility are paramount. As innovation accelerates, these platforms enable air forces to project power, gather intelligence, and respond to emerging challenges worldwide. If you enjoyed this exploration of air power, please consider subscribing to Steelwake for more content.